We're now going to continue section 9.1 and continue our discussion on the ellipse. As a reminder, remember what your formulas look like for the two versions of the ellipse. Recall that if the ellipse is stretched from left to right with the major axis running parallel to the x-axis, then your a value will be underneath the x in the formula. If your a, which is the larger value, is underneath the y, then the parabola is turned this direction with the major axis running parallel to the y-axis. We're going to look at another example. In this example, as you notice, the equation is written in what we call general form instead of the standard form that we're used to. And so before we can begin, we need to convert this formula to standard form so that we can more easily read off the center and the vertex and the foci for our equation. So to rewrite it in standard form, we have to complete the square for both the x and the y variables. So we're going to begin by rearranging our terms. I'm going to write a term that has the x in it, all of those terms together. So that's going to be the 25x squared and the 100x. I'm going to group those terms together because those are both x's. I'm going to write the y terms together. So that will be 4y squared minus 24y. And this 36, I'm going to subtract off and put it on the other side, just so it's kind of out of the way. Now, in order to complete the square, recall that you have to have a coefficient of 1 sitting in front of the squared term. So what I need to do is I need to take these two x terms and I need to factor a 25 to the front. So when I pull a 25 out of a 25x squared, that's just going to leave me an x squared. When I pull a 25 out of 100x, that's going to leave me 4x. We're going to do a similar thing for the y's. For the y's, we're going to factor a 4 out of these two terms. So when I pull a 4 out of a 4y squared, it's going to leave me a y squared. When I pull a 4 out of a 24y, it's going to leave me a 6y. And again, we're doing that because we have to have a coefficient of 1 sitting in front of our squared terms before we can complete the square. Now, remember that your rule for completing the square is that you're going to take the coefficient of the middle term, which will be the 4x and the negative 6y. You're going to half that, and then you're going to square it. So I'm going to do it for the 4 first. So I'm going to take the 4, I'm going to multiply by a half, and I'm going to square. So half of 4 is 2. And 2 squared is 4. So I'm going to add the 4 here, and I want to do the same thing on the other side. Now, keep in mind that this 4 is going to be acted on by the 25 outside the parentheses. So it's not that we just added 4 right here. We actually added 25 times 4. So when I balance on the other side, I need to add 100 because 100 is 25 times 4. All right, let's do the same thing for the y's. So our coefficient of a middle term for the y is negative 6. I'm going to multiply it by a half and square. So half of negative 6 is negative 3. Negative 3 squared will be 9. So I'm going to add a 9 here. And then what do I need to add on the other side to balance? Again, that 9 is going to be acted on by that 4 on the outside of the parenthesis. So 4 times 9 is 36, and that will balance the equation on the other side. Now, once that is done, then I'm going to look at factoring what I have inside my parentheses. So I'm going to try to factor the x squared plus 4x plus 4. So I know that that would need to be x times x to make x squared. And the nice thing about factoring when you're completing the square is that you have to factor into two identical parentheses. So in other words, I couldn't do 4 times 1 for the 4 because then I would have two different numbers. It has to be the same number. So it's going to have to be a 2 and a 2. And they either both have to be plus or they both have to be minus. And since there's no minuses anywhere in my problem, I'm going to go ahead and make them both plus. And so this part becomes 25 times x plus 2 squared. And then we're ready to move on to the y's. Okay, we're going to do the same thing on the y. We're going to factor the y squared minus 6x or 6y plus 9. It would have to be y and y. Remember that you have to use the same two numbers to make 9, so it would have to be 3 and 3. Because we're combining to make a negative 6y, I'm going to make them both negative. And so this is 4y minus 3 squared is equal to, and when we combine our numbers over here, we're going to end up getting 100. Now, remember that in your ellipse formula, they need to be equal to 1. And so I'm going to come here to my formula and I'm going to do that by dividing every term by 100. That would cause it to equal 1 on the right-hand side. And so that's going to give me x plus 2 squared over 25 over 100 is the same thing as 1 over 4. And y minus 3 squared, 4 over 100 is going to reduce to 1 over 25 is equal to 1. And we now have the standard form of the equation of our ellipse. Now we're ready to start thinking about graphing this ellipse. So let's consider what we know about the ellipse that we have. I'm going to erase all of this to give us some room. Let's go ahead and think about the center. All right, what is the center for our ellipse? Okay, so remember that for the center, you're going to do the opposite of the numbers that you see. So if I have a plus 2 right here, it's going to go in as a minus 2 in the center. And a minus 3 is going to go in as a positive 3. So we'll have a center at negative 2, positive 3. We know that the a value is the larger of the two values in the denominators. So that makes the a squared here on the 25 and the b squared on the 4. So that tells me that a is equal to 5, so that 5 squared is 25. And it tells me that b is equal to 2. Because 2 squared is equal to 4. We can use our formula to calculate the c. So a squared minus b squared is equal to c squared. We can plug our numbers in. So we'll have 25 minus 4 is equal to c squared. And so the c value is going to be the square root of 21. Now, let's consider the turn on this ellipse. Since the larger number is underneath the y, what that tells me is that when I start graphing this, and I'm going to go ahead and plot my center. Okay, so there's my center, and if the larger number is underneath the y, it tells me that the ellipse is turned like that. Okay? All right, so let's go ahead and determine our vertice points. Remember that that is going to come from the a value. So we're going to count up 5 units and down 5 units for the vertex. All right, so we're already at 3, so we need to count up 1, 2, 3, 4, 5. So we're going to have a vertex point up here, and that point is going to be -2, 8. And we're going to have another one coming down. So 1, 2, 3, 4, 5. And that's going to be -2, -2. Now we can do the same thing for our co-vertices. The co-vertices are based on the b value, so we're going to go over 2 in each direction. So we'll have a co-vertex at 0, at 0, 3, and also one at -4, 3. And so technically that is enough to do what they asked me to do, which was draw my ellipse. So I can connect those 4 points and have a pretty good idea of what that ellipse looks like. The only other thing that they might be asking you to do would be to do your foci points. And so we can do that as well, even though it wasn't specifically asked for. The foci are going to be based on this square root of 21, which if I put that in my calculator, and that may make it easier for you, that's like 4.6. All right, and so we are going to take our center point and we're going to move up 4.6 and down 4.6. So keep in mind that your x values are going to stay the same, so we'll still be at -2 for the x's, but it's the y values that will change. All right, so our current y value is at 3, and I'm going to then go up 4.6. So that's going to take me up to 7.6. And then I'm going to start at 3, and I'm going to drop down 4.6. So I can do 3 minus 4.6, and that's going to put me at -1.6. And like I said, it didn't ask you for the foci, and you don't necessarily need those in order to graph it. But in a similar problem, you may be asked for the foci. So we'll go ahead and write those down. Okay, and then we can check our graph against the graph from the book, and we see that we are on the right track, that we have the same 4 values, and they did go ahead and mark off those foci points as well. Okay, so let's try one more example in this section. We want to construct the standard form equation for the ellipse that we have shown in the picture. And this is a little bit different because now we're given the picture and we're being asked to write the equation. So I'm going to go ahead and identify my center, which I can do fairly easily here. The center is going to lie in between the co-vertices and in between the vertex points. So I think my center is going to be right here, which is going to be the point 1, -2. So that will be fairly easy to get us started. Remember that we have sort of an opposite relationship between the numbers in the center and the numbers in the parentheses. So if the center has an x value of +1, it's going to go in the formula as a -1. And the same thing on the y. If the y value is -2, it was originally a +2 in the formula. Okay, so the only other things that I really have to do now is figure out the a and the b, and then figure out the turn of the ellipse. So recall that the a is going to be the distance from the center to the vertex. And so I can just count this over. This is 1, 2, 3, 4, 5, 6 units over. And so I know that my a is 6. I know that my b is going to be the distance from the center to the co-vertices. So that looks like that's just a distance of 1. Now, the only other thing I have to decide is where does the a go? Since the ellipse is turned this way, long ways from left to right, we know that the a value, the larger number, was underneath the x. So I can go ahead and plug that a value in. Remember that it is squared. And by default, the b value is going to go underneath the y. All right, so once that's done, we can simplify things just a little bit. 6 squared is 36. And 1 squared, we wouldn't typically write 1 squared at all. We would just simply leave it like this. And so that gives me the equation for my ellipse.